Okay, question 5 is on finding the nth term of a sequence. We've got two sequences to find the nth term for. So the first one, 7, 10, 13, 16, 19. So the first one to do is work out how I'm getting from one term to the next. So you can see that to get from 7 to 10, I add 3. 10 to 13, I add 3. And 13 to 16, I add 3, and so on. So always double check your rule works for more than just one pair of numbers, so check it works for all of them. So my rule is add 3. That means that in my nth term, the number before the n is 3. So the number in front of n is always the difference between the numbers. Now I need to work out what I'm going to add or subtract from 3n. So one way of doing this is working out what the 0th term would be, or in other words, what number would come in our sequence before our first number. So what number would come before the 7? So remember, we're adding 3 each time, so the number that would come before 7 would be 4, and that is the number that you add to the end of your nth term. So the answer is 3n plus 4. The 3 comes from the fact we're adding on 3 each time, and the 4 comes from the fact that that would be the 0th term, the term before 7. So that's part A, that's a linear sequence. Okay, so if we look at this one here, to get from 2 to 5 I add 3, to get from 5 to 10 I add 5, 10 to 17, I add 7, and so on. So this is why it's important to double check your rule works for more than just one pair. So for here, we're going up a different number each time, which means it is not a linear sequence. So if that's the case, then what we're going to try instead is a quadratic sequence. So that involves n squared. So what I'm going to do is I'm going to write out for an nth term of n squared what my sequence of numbers would be. So remember, we've got first term, second term, third term, fourth term, etc. So n squared would be 1 squared, which is just 1, so my first term would be 1. The second term is 2 squared, which is 4. Third term is 3 squared, which is 9. Fourth term is 4 squared, which is 16. And so on. So if my nth term was n squared, I get 1, 4, 9, 16. However, I don't have 1, 4, 9, 16. I've got 2, 5, 10, 17, etc. So how do I get from this line to this line? Well, we can see that to get from 1 to 2, I add 1. To get from 4 to 5, I add 1. 9 to 10, I add 1. 16 to 17, I add 1. So my nth term would be n squared, which gets me to here. Then to get to the actual numbers I want, I have to add 1. So my nth term would be n squared plus 1.